Good morning, ladies and gentlemen. Welcome back to the Calculus AB practice test. We're working on the 2019 FRQs. In this video, we're going to try to tackle number 5. Hopefully, it takes us less than the 15 minutes allowed. In this question, we cannot use a calculator. All right, so it says that Brandon and Chloe, they're going to ride their bikes for 4 hours. Brandon's velocity is given by a differentiable function b, and we have a table for that. Chloe's velocity is given by c of t, and we have a piecewise function for that. How many miles did Chloe travel from 0 to 2? To calculate how many miles Chloe traveled, we have to figure out the net change. So we're going to be doing the integral from 0 to 2 of c of t dt. We're really careful because we do have a piecewise function. That doesn't mean you're going to be integrating both functions. We're only going to be integrating the function that is defined on the interval from 0 to 2, which makes it this function. Now, in order for me to do this, I'm going to go ahead and do u substitution. My u, I selected u to be 4 minus t squared. So my derivative with respect to t is negative 2t dt. And my suggestion for you is to isolate dt. So we divide by negative 2t on both sides. And we're going to be using this to replace the dt. So here we have the integral of t e to the u times 1 over 2t du. Now, the other thing I'm going to do with u substitution is I'm going to change my limits of integration. I don't want to have to go back to what I selected for u. So if I plug in the 2 into the equation that I chose for u, then I'm going to get 0. And if I plug in 0, I get 4 minus 0 squared, which is 4. Okay. So for my next step, we're going to do a couple of things. First, we're going to flip the integral so that it's from 0 to 4, making my integral a negative. And 2, we're going to cancel out these t's. That leaves me with 1/2 e to the u du. Now, what's the antiderivative of e to the u? Well, it's just e to the u. And we're going to be evaluating that from 0 to 4. I kind of ran out of space, so I have to do my work sideways. Sorry for that. So we have negative 1/2. And in parentheses, I'm going to do my f of b minus f of a, which is e to the 4 minus e to the 0. And that gives me negative 1/2 e to the 4 minus 1. You can leave it like this, or you can distribute the negative 1/2. Either way, it's not going to make a difference. But this represents the miles traveled by Chloe. From t is equal to 0 to t is equal to 2. Okay. Part B. Is Chloe's speed increasing or decreasing? Right. So this is a little tricky, right? We're talking about speed, not velocity. And in order for speed to be increasing, velocity and acceleration must have the same sign. But if they have different signs, then that means the speed's going to be decreasing. Speed decreases. So we're going to do both things. We're going to find the velocity at t is equal to 3. And we're going to find the acceleration at t is equal to 3. But first, about the velocity. If I look at my piecewise function, make sure that you're using the appropriate equation for this. We have to use this equation. That's where That's where t is equal to 3 is defined. And this equation is already velocity. So really careful about what it means. So c of 3 is 12 minus 3 times 3 minus 3 squared. C of 3 is going to simplify to -6. That's Chloe's velocity at t is equal to 3. Now, Chloe's acceleration. Well, for that, we're going to have to first find a derivative. And my derivative is -3 minus 2t. Now we need to find that acceleration at 3 seconds. No, 3 hours. So there it is. At 3 hours, the velocity for Chloe is negative and her acceleration is negative. So, since, you know what, I'll keep my notation the same. Since the velocity is positive and the acceleration is positive at t is equal to 3, Chloe's speed is increasing. Okay. Is there a time at which Brandon's acceleration is equal to 2.5 miles per hour? Oh, miles per hour per hour. Justify your answer. So this equation to me right off the bat is screaming mean value theorem, because now they're saying is his acceleration, is Brandon's acceleration equal to 2.5? We're going to be able to check that by actually finding the average rate of change, which, again, is the mean value theorem. So my job is going to be to calculate Brandon's velocity, average velocity from 0 to 4. And hopefully that gives me the 2.5 that I'm looking for. So let's go ahead and work it out. B of 4 minus B of 0 divided by 4 minus 0. And if I look at my table, B of 4 is 11, B of 0 is 1, and this is actually 2.5. So that basically tells me all I need, right? Now we're going to say yes. By the mean value theorem, Brandon's acceleration is equal to 2.5 miles per hour. Let me take a look at the beginning of the problem real quick. Brandon and Clay, they ride their bike. Brandon's velocity in miles per hour is a differentiable function. There it is. That's the key that I was looking for. Because they're telling me that the function is differentiable, that also means it's continuous. And that's part of the conditions for the mean value theorem. So by the mean value theorem, Brandon's acceleration is equal to 2.5 miles per hour since B of t is continuous on a closed interval. Whenever you're using the mean value theorem as justification, you have to make sure that the function is continuous, and differentiable. I'll add that to my answer. And differentiable. You could just say differentiable because that implies continuity on a closed interval. If the function is not differentiable, you can't use the mean value theorem as justification. So just keep that in mind. The last part. Is there a time in which Brandon's velocity is equal to Chloe's velocity? I suppose this was a little tricky because we have a table for Brandon and we have an equation for Chloe. But here's what I'm going to do. I'm going to calculate both of their velocities at t is equal to 0. So for Brandon has a velocity of 1 mile per hour at t is equal to 0. And Chloe's velocity, well, for Chloe's velocity, I'm going to have to calculate it. I'm going to have to use the equation t times e to the power of 4 minus t squared. And that's where I can plug in my 0. So Chloe's velocity happens to be 0. At the beginning, Brandon has a higher velocity. What happens later? Let's say at t is equal to, and there's no way for us to know. You're just going to have to pick another value. Let's see if 2 works. Brandon's velocity at 2 hours is 1.5 given by the table. And then Chloe's velocity at t is equal to 2. I'm still using the same equation. I'm still using the top piece. So let's calculate that. So it's going to be t times e to the power of 4 minus t squared. Chloe's velocity is 2. Now we have everything we need. So is there a time when Brandon's velocity is equal to Chloe's velocity? Yes. Since Brandon's velocity at the beginning is greater than Chloe's velocity, and later on, Brandon's velocity is less than Chloe's velocity, so that should be a 0 parentheses. Oh, and I'll say something else. And since both velocity functions are continuous, on a closed interval, Brandon's velocity will equal Chloe's velocity by the intermediate value theorem. Think about the explanation for a bit. If Brandon started with a greater velocity, and then later at some random time, Chloe has a greater velocity, and these functions are continuous, they must have intersected at some point. And I'll even give you a graphical explanation for this. Brandon started at 1, and he ended at 1.5. Chloe started at 0, and she ended at 2. And because the functions are continuous, at some point, they must have been equal to each other. At least once. There could have been more times, but they will be equal to each other. Okay. So that right there, ladies and gentlemen, is the closes off question 5. I'll see you next time for another FRQ question.